What exactly lies at the edge of the observable universe? Well, this has remained a mystery for centuries, fueling curiosity and speculation among scientists and enthusiasts alike. However, the James Webb Space Telescope holds the key to unveiling this cosmic mystery. With its powerful lenses peering deeper into space, it has recently made a groundbreaking announcement of what lies at the edge of the observable universe. When we talk about the edge of the universe, it's essential to understand the concept of the observable universe. The observable universe includes everything that we can see, measure, and study from Earth or our space-based telescopes and exploratory probes. At the present time, it consists of stars, galaxies, and other celestial objects that are within our observational reach. So what's the difference between the universe with a capital U and the observable universe? In simple terms, the observable universe is just a small fraction of the entire universe that we can study and comprehend. While the complete size and shape of the entire universe are unknown, there is an estimated diameter of the observable universe, which is around 93 billion light-years. Now, a light-year is a unit of distance that light travels in 1 year, which is about 5.88 trillion miles, or 9.46 trillion kilometers. So, the diameter of the observable universe, 93 billion light-years, is an unimaginably vast expanse spanning approximately 546 billion trillion miles, or 878 quadrillion 44 trillion kilometers, expanding at an increasingly faster pace driven by enigmatic forces like dark energy. As the universe expanded, particles of matter started clustering together due to the force of gravity, forming or inspiring structures such as stars, galaxies, and eventually even planets like our beloved Earth. Over countless years, these cosmic structures grew larger and more intricate, leading to the extraordinary diversity of objects and phenomena that we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we scaled down our entire solar system to the size of a quarter, the nearest star would still be the distance of 2 soccer fields away. And this is just within our Milky Way galaxy, which is one among billions in the observable universe. You may wonder why we can't see the entire universe. There are 2 factors that explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we're actually observing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. So, by observing distant galaxies, we're essentially peering back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself stretches. This expansion causes the light from distant objects to become stretched, shifting towards longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they recede beyond a certain distance. Considering these factors, it's not surprising that we haven't seen the entire universe yet. Now, the concept of the edge of the universe is a mind-boggling topic that has fascinated scientists, philosophers, and thinkers for ages. We have all sorts of theories about what lies beyond, but the truth remains elusive. However, there are 3 theories that stand out. The first theory is that the universe goes on forever with no end in sight. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning that it looks roughly the same in every direction. If this principle holds true, it implies that the universe stretches on endlessly without a boundary. The second theory suggests that the universe is finite, but doesn't have a clear edge either. This means it's similar to a giant ball, and if you keep going in any direction, you'll eventually loop back to where you started. The third theory is the multiverse theory, which suggests that our universe is just one of many. Imagine a bunch of parallel universes, each with its own set of rules and properties. These universes could be completely separate from each other or somehow connected. So, we've talked about concepts surrounding the edge of the universe by looking at diverse theories. Now, let's turn our attention to a remarkable tool that holds the potential to shed light on these mysteries: the James Webb Space Telescope, JWST. This incredible telescope allows us to look far back in time and discover unexpected objects from the early days of the cosmos. The JWST, with its advanced capabilities, has enabled astronomers to peer back into the early days of the universe. And guess what? They've stumbled upon something unexpected. In a recent study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only expecting to find small, newly formed galaxies, but the JWST caught them by surprise. These galaxies are way larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. But that's not all. Scientists also found something mind-boggling. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. The massive stars within each of these objects total several billion times larger than that of our Sun. According to the research, one of them in particular might be as much as 100 billion times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to roughly 60 billion suns. You see, this telescope has a special power. It can see things that are invisible to our eyes. By using infrared light, it picks up the faint glow from old stars and galaxies that have been around for ages. This means that JWST can literally take us back in time, providing a glimpse of what the universe looked like around 13.5 billion years ago. Now here's where it gets really interesting. The universe is estimated to be around 13.7 billion years old. So, this discovery has turned things upside down. It's like rewriting the history books. These gigantic galaxies, nicknamed universe breakers, have scientists scratching their heads. They defy 99% of the models we had for early galaxies. We used to think galaxies started as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the Webb data and high-resolution photos from the telescope became available in July 2022, researchers were blown away. They were taken aback when they saw these galaxies as significant points of light, doubting their own interpretation of the data. The sudden appearance of these colossal objects, almost as if they wanted to be found, surprised everyone. By using spectroscopic techniques to analyze light across different wavelengths, scientists can uncover valuable information about these galaxies, such as their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even on the top of the list of things scientists hoped to find with the James Webb Telescope. It exceeded all expectations and unfolded much quicker than anticipated. There's even a possibility that some of the objects found using Webb data may be something entirely different. While most are likely galaxies, there's a chance that a few could be hidden supermassive black holes. Here's the intriguing part. The known mass of stars in the universe is now believed to be up to 100 times more than we previously thought. This discovery is still mind-blowing even if we consider only half of the sample. Meanwhile, using the powerful James Webb Space Telescope, JWST, an international team of astronomers also made an incredible discovery. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to a time when the universe was just a fraction of its current age, fewer than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Similar to the early observations made by the Hubble Space Telescope, the initial images captured by the JWST revealed numerous potential galaxies. Now, through meticulous spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the physical properties of the galaxies, but also to accurately determine their distances. To determine a galaxy's distance, astronomers calculate its redshift. You may be wondering, what is redshift? Well, it turns out that as the universe expands, objects appear to move away from us, causing their light to stretch and shift towards longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be derived from photos taken through various filters, spectroscopy is the preferred method for obtaining precise measurements, as it breaks down the object's light into its constituent wavelengths. The new discovery focused on 4 galaxies with redshifts greater than 10. This means they are super far away. The Hubble Space Telescope previously spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. But the JWST images revealed 2 even more distant galaxies, with redshifts of 13.20 and 12.63. Redshift 13.20 indicates a time period roughly 13.5 billion years ago, revealing ancient cosmic history. Moreover, the JWST Advanced Deep Extragalactic Survey (JADES) is an ambitious program that has been allocated over a month of the telescope's time. Its objective is to provide an unprecedented in-depth glimpse into the early cosmos. In 2015, a consortium of instrument teams proposed this project, forming an international partnership known as JADES, comprising more than 80 astronomers and scientists from 10 different nations.